Dia
Sudah
banyak,
penuh sepenuh.
dia sudah penuh lah. Tengok cerita lucah banyak sangat. Kena kerja dulu.
Itulah kena save kat Google Drive. Tak ada water ni sudah.
Siapa? Nama je belajar
Continue sir,
computer.
continue sir, continue.
Okay. Now. Yeah. So we know, right? Metal, right? They have a lot of free electron. Okay. So let's say if you have a metal, inside metal there's a lot of free electron. So what happens when you heat up the metal? Okay. So what happens? This electron will gain energy. Now, if the energy is big enough, what happens? The electron can come out from the surface of metal. Okay. So this one we call it thermionic emission. Okay. Process where electron emitted from surface of heated metal. Okay. So process where electron is emitted from surface of heated metal. Okay. Now, next we look at the definition of cathode ray. Now, cathode ray is beam of electron moving at high velocity. It's beam of electron moving at high velocity. It is produced using an electron gun. Okay, so it's a beam of electron moving at high velocity. So it is produced using an instrument, we call it as electron gun. Now, basically, electron gun, okay, so consists of, okay, the filament here. So the filament will act as a cathode. Okay, and then the other end you have the anode. Okay, so filament consists of a cathode and anode. Okay, so it consists of cathode and anode. Okay, so now, so what happened? Okay, so now the filament is connected to a low voltage supply. So when you on the filament, right, what happened? The filament get heated up. Okay. Now, when the filament get heated up, what happened? The filament will release electron. This one call it thermionic emission. Okay. So this one call it thermionic emission. So when the current passes through the filament, filament get heated up. Okay. So what happened? It will release electron. So this one call it thermionic emission. Now, during this time, what happened is, okay, the anode is not on yet. Kita belum on the anode. It's open. Okay. So the anode is, okay, close. Okay, anode is not on yet lah. So we don't on the anode yet. Okay. So what happened? You see, when I on the anode, so the electron will be attracted towards the anode. Okay. So this beam of electron, so you see there's a beam of electron. So this beam of electron we call it as cathode ray. Okay. So this beam of electron moving at high velocity we call it as cathode ray. Okay. So electron gun basically consists of a filament. Okay, consists of a filament. Okay, this filament will act as a cathode, and then you have an anode. Okay, so basically what you call it, electron gun is all about lah. Okay. Next. Okay, now next we're going to look at what is the property of cathode ray. Okay. Okay.
Aduh.
Mana Iman?
Apa?
Oh, tak boleh pula Faiz lah.
Apa ni?
Tak ada. Now, so now next we look at properties of cathode ray. Okay, now this experiment, right, uses an instrument we call it as a multi-cross tube. So this is a multi-cross tube. Now a multi-cross tube exactly like your electron gun. There's only a few things extra. So basically you have an filament here, and then you have the anode, and then you have the cross. Now the cross is just an obstacle, and then you have a screen here, we call it a fluorescent screen. Now this screen is coated with a special material where when the electron hits the screen, it produces light. Okay, just like your TV lah. So when hit by electron, okay, it will produce light. Okay, so when hit by electron, it produces light. Okay, now. Okay, so what happened is, okay, so you have cathode, you have anode, okay, there's a cross, and then there's a fluorescent screen. Okay. So this is how your multi cross tube will look like. Mana video?
Kantor.
Nampak video tak? Tak ada.
Tak ada.
Ni. Ini semasa saya mengajar dekat US dulu. Okay. Now. So this one, right? You nampak. Okay, this is a multi cross tube. Okay, so nampak screen putih ni So this one we call it a fluorescent screen. Okay. So basically this is how your multi cross tube, okay, will look like. Okay, So you have the filament here, and then you have the anode, and then you have the cross here, just an obstacle, and then this is a fluorescent screen lah. So dia nampak macam bulb. It looks exactly like a bulb. Okay, it looks exactly like the bulb. Okay, now, so so we look at the procedure of the experiment. Okay, now the first situation, right? So what we do is we on only the 6-volt heater supply is on. That means we only on the heater. We only on the filament. Sorry, we on the filament. You see, when you on the filament, when the current passes the filament, what happens? It get heated up. So what happens? Electron will be released. Okay, that means thermionic emission will happen lah. So electron will be released. Okay, so during this time we don't on the anode yet. It only on the filament. Now, so what happen is, okay, suruh Kogu guna bapak punya phone lah. Daripada tadi dia cuba tak boleh. Okay, so what happened? It will release electron. Okay, now, so now during this time there's no cathode ray because we haven't on the anode then. So anode, okay, it's not on yet. Okay, anode tidak di on lagi. We only on the filament. So what we able to see is, you see what happened is, now the filament get heated up, we release electron. Other than that, the filament also will be able to produce light. Okay, because the filament will glow, dia akan membara. So kali datang lewat
Dah
lah.
masuk.
Tajuk apa tu?
Kalau pukul 5 kelas, pukul 4:30 dah cuba masuk.
Forget lah.
Sudah lupa. Tengah syok sendiri tidur ni.
Cakap pun macam orang mabuk. So what happened? Now, so okay, what we're able to see is, okay, we only on the filament. Okay, kamu akan nampak apa? The stream. Okay, you be able to see shadow. Okay, so shadow on the screen. Okay, you can see the shadow of the cross. Okay, so kamu akan nampak shadow on the screen. Okay, so we're able to see shadow on the screen. Okay, now why? Because you see the filament, other than producing electron, also produces light. So light travel in a straight line. Okay, so light travel in a straight line. So since light travel in a straight line, so that means the light cannot penetrate the cross here. So that's why we're able to see the shadow. Kamu akan nampak bayang. Okay, bayang cross pada screen. Okay, so this is what happened lah. Okay, so this one if you only on the filament, okay, you'll be able to see shadow because light travel in a straight line. Okay, next. The second procedure. Second procedure. Okay, what we do now is we're going to on the filament and the anode. So kita akan on both filament and anode. Now, when you on the filament and anode, what is going to happen is, okay, we know that electron will be released by the cathode, and then this anode is going to pull the electron. So cathode ray will be produced. So you can produce cathode ray. Okay, be able to produce cathode ray lah. Now, what you'll be able to see on the screen is you'll be able to see, okay, the screen. Okay, ini before we on the anode, before you on, only on the filament. This one also still on the filament. Now, the moment you on the anode, you dapati dia punya screen akan bertukar warna hijau. Okay, the screen become green in color. Okay, the screen become green in color. Okay, so why it become green in color? Because the cathode ray will hit the screen. Okay, so the cathode ray will hit the screen. Okay, so the fluorescent screen will glow lah. Okay, dia akan bercahaya. Okay, so it becomes green in color. Okay, it becomes green in color. Okay, now, sekarang kita tengok video lain pula. Ini video daripada St. John.
Ayo, tak mau lah. Saint Mary CBN tak ada kak? Ya, aku boleh nampak seorang dengan cermin mata baju biru.
Ni, nampak?
Mana ni? Ayo.
Ini mak-mak yang
Siapa
paling,
ni?
mak-mak yang paling miskin dekat dunia ni lah.
Wah. Mudanya.
Ini bila? 20 tahun lepas ke?
Ha?
20 tahun lepas punya video kak?
Okay, so you see, it'll be green in color. So this one,
Sekarang
when you
jawab.
on the filament, when you on the anode, it become green in color. Okay, now the thing is, what happen when you bring the magnet? Now, if you bring a magnet, you see that the shadow actually will start to move. Okay, so bila kamu bawa magnet, kamu dapati shadow tu dalam kes ni naik ke atas. Nampak dia naik ke atas. That means the cathode ray can be deflected by electric field. So video ni saya ambil tahun lepas. Saya tahu tahun ni corona akan berlaku, so saya ambil awal-awal tahun lepas. Tengok, saya boleh predict. Okay. Malapetaka akan berlaku sebab ada COVID. So,
Alright.
so you can see, right? Okay, when you bring the magnet, you see the shadow will start to move up. Okay, the shadow move up. That means the cathode ray can be deflected by magnetic field. Okay, can be deflected by magnetic field. Okay, dia boleh dipesongkan oleh magnetic field lah. So bila kita bawa magnet. So kalau kita keluarkan magnet, you can see the shadow will move in the middle again. Okay. Now the thing is, we want to know how to determine the direction of deflection. How we know the magnet? How we know the shadow goes up? Okay. Now, so this one you have to use your Fleming left-hand rule. Okay, Fleming left-hand rule. Okay, contoh macam ni So let's say you have a magnet here. Okay, this is your north pole. So here will be your south pole. Okay, so you see what happened when I bring the magnet down. Okay, now first of all, so we already on everything. Okay, so what happened is, okay, this one actually is supposed to be all in green color. Okay, semua ni green color except the shadow lah. Shadow tu warna hitam. Okay, so all these must be in green in color. So what happened when you bring the magnet? So when you bring the magnet here, what happened is, see, for this example, the shadow goes down. Okay, the shadow goes down lah. Now, how to determine? This one you have to use your Fleming left-hand rule. Okay, Fleming left-hand rule Okay. So it's like this Okay. So let's say this is your magnet. Okay, for this example, here is north, here is south. Okay, and then this is the multi-source. Okay. Okay, so this is the shadow lah. Okay, so how to determine, right? Okay, so for this one, you have to use your Fleming left-hand rule. Okay, you have to use your Fleming left-hand rule. Okay. Now, okay, for Fleming left-hand rule, Okay, for Fleming left hand rule, right? Okay, this one is your force, force, magnetic field current, FBI, FBI. Okay, you see, right? Let's say if this is your screen, like you're watching television, right? Now, if you're watching television, it's your screen. Now, the filament will be at the back. Okay, filament will be at the back. That means the electron is going out. Now, when the electron is going out, that means the current going in. Okay, remember, electron going out, that means current going in. That means when you use your Fleming left hand rule, okay, so what you must do is, okay, not hands out this way, your current must be pointing inwards. So you have to point inward, kena tunjuk ke dalam. Okay, because electron coming out, that means current going in. So where is your force? Ibu jadi tunjuk ke bawah. So that's why for this example, the shadow will go down. Okay, so that's why for this example, the shadow will go down. Okay, so that's why when you bring the magnet, it goes down. Okay, shadow goes down. Okay, so use your Fleming left hand rule. Okay, so okay, north to south, and then your current going out. Current pula. Electron going out, that means current going in. So jari ketiga tunjuk dalam. So force is downward. Okay, so that's why the force is downward. Okay.
Or it can be deflected by magnetic. Okay. So this experiment, the going in is coming out. That means your current is going in. So the third finger must be pointing inwards. So that means what happens? Your force is upward. So that's why the shadow goes up. Okay. So that's why the force is upward. Okay. See, shadow goes up. So your thumb also goes up. Okay. So you have to use your Fleming left hand rule. Okay, to determine the direction of deflection. Okay, so that means your cathode ray can be deflected by magnetic.
So for this example, right? Okay, so here is my north, here is my south. Okay. Okay, so that means, right? That means your second finger must be pointing this way. So north to south. Okay, north to south. That means the electron is coming out. That means current going in. That means your third finger must be pointing inward. So that's why you see the force is upward. Okay, so use your Fleming left hand rule. Okay, use your Fleming left hand rule. Okay, so you have to use your Fleming left hand rule. So north to south, that means when the electron, okay, coming out, that means current going in. Okay. Okay, next. Now, what happens if we take the cathode ray? Okay, we put it inside electric field. Okay, so if we put inside electric field, what can happen is you see that the cathode ray will be deflected upward. Okay, the cathode ray will be deflected upward. Okay, why the cathode ray deflected upward? Because cathode ray is negatively charged. So cathode ray is negatively charged, that's why deflected upward. Okay, so this one is positive, this one negative lah. Okay, so the cathode is negatively charged, so deflect upwards. Okay, so what happened is, okay, so from there we can get the properties of cathode ray. Now these are the important properties of cathode ray. First, it is the negatively charged particle we call electron, and then travel in a straight line. Okay, and then cast sharp shadow lah, if there is a shadow. Okay, if there is a shadow. Okay, next. Okay, next. Travel at a very high speed and have high kinetic energy. Okay, and then can cause frozen situation where kinetic energy converted to light. Okay, and then deflected both by electric and magnetic field. So cathode ray can be deflected by electric and magnetic field. Okay. Next, we're going to look at how to determine the velocity of electron. Okay, this one involves a formula. You see, what happened is, now, let's say this is your cathode, this is your anode. Okay, cathode is the filament lah. So what happened is, when you on the anode, you see that the electron will start to move towards anode. That means the electron will gain kinetic energy. Now, where does the kinetic energy come from? Now, the kinetic energy actually comes from your electric energy. Because, right, when you apply voltage, when you apply voltage between cathode and anode, when you apply voltage in cathode and anode, what happens? from the formula, voltage is energy over charge. Okay, so voltage is energy over charge. If I cross multiply, I get energy equals to voltage times charge. Now, this energy is your electric energy. Okay, so this energy is your electric energy lah. So when you apply voltage between anode and cathode, what happens? There will be electric energy. So this electric energy will be converted into this electric energy is converted into kinetic. Okay, so the electric energy will be converted into kinetic energy. So that's why the electron is able to move. So that means EV equals to half mE square. Okay, EV equals to half mE square. Okay, so EV equals to half mE square. Okay, now because why I put E here, because we are looking at electron. So since we are looking at electron, so the Q we change to E. So it becomes EV or VE lah. So electric energy equals to VE or EV, up to you. Okay, so electric energy equals to VE or EV. Okay, so this V will be your voltage. Okay, so this V is your voltage. This small v will be the velocity of electron. Okay, so the small v will be velocity of electron, the big V will be the voltage. So that means when you apply voltage between cathode and anode, what happens? Okay, there will be electric energy. So the electric energy will be converted into kinetic energy. Okay, now, so we look at example of question. Potential difference between anode cathode in an electron gun is 5 kilovolt lah. So calculate the kinetic energy of the electron. So kinetic energy. So now here formula for kinetic energy is half mE square lah. Half mE square. But for this question you cannot use this one. Why? Because we do not know the mass, we don't know velocity. So what we're going to do is we're going to use the conversion of energy. That means where does the energy come from? Okay, where does the energy come from? Now the energy actually comes from electric energy. So what you do is you calculate the electric energy. That means you calculate the EV. Okay, so the kinetic energy comes from the electric energy. So you calculate the EV. Okay, so EV. Okay, so this one will be 1.6 times 10 to the power of negative 19. Okay, and then the voltage is 5 kilovolt. So 5 times 1000. Okay, so you press a calculator, you get 8 times 10 to the power of negative 16 joule. Okay, so 8 times 10 to the power of negative 16 joule. Okay, next. Now, in the vacuum tube of a television receiver, a cathode ray is produced and accelerated to potential difference of 7 kilovolt. So determine the velocity. This one they want the velocity, so you have to use half mE square equals to EV. Okay, so half mE square. Kinetic energy equals to electric energy lah. So half. Okay. Why? Why you raise your hand?
Ter. Nak tekan chat.
Main chat dengan kau ni. So half mE square. So M is 9 times 10 to the power of negative 31. Okay, times V square. Okay, equals to E. E is 1.6 times 10 to the power of negative 19. Okay, and then the voltage will be 7 kilovolt. So change to 7000. Okay, so sekarang ni, what you must do is, okay, you want to find the V right now. The best thing is you try to simplify 9 and 2. So 9 divided with 2, what do you get? Cash winner, cash.
Woo! You
Dalam
tanya
berapa?
esok tak dapat.
4.5 lah. Ini pun tak tahu. Okay.
Cash.
So V square equals to 1.6 times 10 to the power negative 19 Okay, negative 19
Times
times
7,000.
7,000. Okay, and then you have to divide with, okay, this 4.5 times 10 to the 131. Semua bawa ke bawah. So 4.5 times 10 to the power negative 31. Okay. So you see, when you press divide, right, you make sure there's a bracket here. If there's no bracket, you get different answer. And then you square root. Remember, this is v squared. So you need to square root. Berapa jawapan dia? So 1.6 times 10 to the power negative 19. And then you times 7,000. And then divide with 4.5. Make sure there's bracket. 4.5 times 10 to the power of negative 31. Okay. So get this lah, this answer. Nampak tak? 2.44 ni. Bukan jawapan akhir lagi Then you square root the answer. You akan dapat ni. Nampak? So so you round off lah. So that means your answer will become
50.
4.99 times 10 to the power of, kalau hutang kau 50, 10 to the power 7.
Dah round off lagi lah, sir. Tak boleh tak? Sir, just now 49.9, right?
4.99 lah. Where got 49.9?
Seriously?
49,000.
Guru.
No, 49 million. 888,765. Tengok betul-betul.
Sorry, boss. Ya.
Mata pun tutup ni. Semalam apa?
Habis lah.
Kau ni.
Ni habis.
Next. Okay, so we look at example of structured question. Okay, look at question number 18. Now, diagram shows a cathode ray tube. Okay, kamu punya soalan ni gambar aja sudah hilang. Okay. Refer to this. Okay, this is actual diagram. Mana dia? Okay. Mana dia? This one. Okay, this is the actual diagram. This one. So diagram shows a cathode ray tube. Okay. So the first question okay, what is the meaning of thermionic emission? And I refer to this diagram. This is the actual diagram. Okay. So what is meant by thermionic emission? So you refer to your notes. Okay. Definition is.
Wait, daing. Mute.
Process of emission of electron from surface of heated metal. Okay. Process of emission of electron from surface of heated metal. Okay, so you must have the emission of electron from surface of heated metal. That means the metal get heated up. If the metal doesn't get heated up, you won't get the electron. Okay, Next. Okay. Now, what is the function of anode? Now, so we know, right, what happened is, okay, this is your anode. So when the anode becomes positive, what happens is going to attract the electron. That means the electron that's being released here will be attracted by anode. Okay. So what happens is, when the anode attracts the electron will gain kinetic energy lah. Okay. The idea of the anode is to accelerate the electron, so that the electron will get a very high kinetic energy. So when it hit the screen, it will be converted into light. Okay. So the function of anode in this case will be to accelerate. Okay, to accelerate the electron. Okay, to accelerate the electron. So the function of anode is to accelerate the electron. Okay, now why the tube must be vacuum? Now because if there is air inside here, that means when the electron travel, it's going to experience collision with the air particles. So the electron cannot travel in a straight line. Okay, so they start to move. Okay, not in a straight line anymore lah. So that means why it must be vacuum. You can say to prevent prevent collision with air particles. Okay, to prevent collision with air particles lah. Now next, what happened when the electron? What happened to the electron when the current flowing to the filament increase? See what happened? Now when we increase the current to the filament get heated up more. So that means more electron will be released. Okay, because the filament becomes hotter, so you can release more electron. So the answer is more electron. Okay, more electron is emitted. Okay, more electron is emitted. Okay, next. The voltage of 5 kilovolt power supply is increased. Now, the voltage of 5 kilovolt. Now, what the voltage is this? This is voltage of anode. Okay, this is the voltage of anode. So, this 5 kilovolt is your anode. So, A is your anode. So, what happens is when you increase the voltage of anode, that means the anode becomes more positive. So, the anode becomes more positive. That means it can pull the electron with stronger power, stronger force. So, actually, what is going to happen is the electron is going to travel very fast. Okay, the electron is going to travel very fast. Okay, why? Because the anode now is more positive. So, you're able to attract the electron faster. That means what's going to happen is the speed of electron will increase. Okay, the speed of electron will increase. So, mana head boy? Tak ada.
Dia dekat Kelantan, sir.
Mana boleh balik? Hui. Mana boleh balik? Kena tangkap ni semua tu.
Tak ada capaian internet.
Ha?
Tak ada capaian internet.
Tak, hari tu raya. Mana boleh rentas negeri?
Ada permit kot. I pun tak sure, I tak tanya.
Mana ada permit? Semua tak boleh lah.
Don't know.
Next. Now, the switch is closed. Now, what happened when you close the switch? Okay, now when you close the switch, okay, now we are talking about this switch. Okay, what happened is this P is connected to the positive terminal. So P become positive. Okay, now what happened to Q? Q become negative.
Negative.
Okay, so what happened is when the cathode ray travel, the cathode ray will be deflected upward. Why? Because negative attracted towards positive. So Aiman, negative attracted towards positive.
Apa?
Charges will attract. Opposite charges will attract. Same charges supposed to repel. Okay.
But tak apalah, Aiman nanti marah aku.
Okay. So what happened is you say what happened to the, dia tanya what happened to the electron kan? So you tulislah deflect upward. So deflect upward. Okay, so deflect upward. Okay, E. What happened to the energy possessed by the electron when hit the screen? So the energy will be converted to light. Okay, so converted. Okay, converted to light. Okay, so converted to light. Okay, next. The potential between the filament and anode is 9 kilovolt. Calculate the kinetic energy of the electron. So this one they want the kinetic energy lah. So this one you can use okay, EV. So this one just use EV. So 1.6 times 10 to the power negative 19 times with, okay, the voltage is 9 volt, so 9,000. Okay, so 1.6 times 10 to the power of negative 19. Oh, 9,000. 1.44. times 10 to the power negative 15. So it's going in joule. Okay, next they ask you to find what is the velocity of the electron. This one you have to use half me square equals to EV. So half. So M kamu ialah 9 times 10 to the power negative 31. Darab V square. Okay, just now the energy, right? 1.44 times 10 to the power negative 15. Okay. So sama seperti tadi sebelum kamu pindah pemudahkan ni So 9 tu akan jadi 4.5. Okay. So maksudnya V square sama dengan 1.44 times 10 to the power negative 15 bagi dengan 4.5 times 10 to the power negative 31. Okay, so make sure square root your answer lah. Okay, square root your answer. Okay. Okay, so you get the answer. So I think you get around 4.5 times 10 to the power of negative 31. Square root answer. So, jawapan kamu dalam bentuk standard form So 5.66 times 10 to the power of negative 10 to the power 7 ms negative 1. Okay, ms negative 1. Okay. Okay, next we look at number 19. Okay. Now diagram 3.1 shows a cross section of a multi-source tube to study the characteristic of cathode ray. So what is the meaning of cathode ray? So cathode ray is beam of electron. Okay, moving at high velocity. Okay, so beam of electron moving at high velocity. Okay, next. When switch S1, S2 are turned on, two overlapping shadows are formed. Okay, so basically why they are shadow lah. Now when you on the filament, what happened? Okay, the filament get heated up, the filament release electron and produce light. So from there you get one shadow because of the light. And then when you on the anode, we get the cathode ray. That means we add the electron. We have the electron start to travel. So the cathode ray also will make a shadow lah. So this shadow will be overlapping. So why we see the shadow? Because both the cathode ray and light, they travel in a straight line. So that's why we see the shadow. Okay. So for this one, you can see, so why we see the shadow? Because light and cathode ray travel in a straight line. Okay, light and cathode ray travel in a straight line. Okay, that's why you see the shadow. Okay, next. Calculate the velocity of the cathode ray in the matrix tube. So they give you the charge, they give you the mass. Okay, now the voltage of the anode here is 3 kilovolt. This is the voltage of anode. Bukan ni voltage filament. Anode ialah 3 kilovolt, 3000 volt. Okay. So this one boleh guna okay. So this one can use so half mv square equals to EV. So half times 9 times 10 to the power negative 31 equals to, so your E will be 1.6 times 10 to the power negative 31. 19. And then it times with 3000. Okay. So what you do is simplify this half and 4. So it becomes 4.5. So it's supposed to be B square. So your B square will be 1.6 times 10 to the power negative 19 times with 3000 divide by 4.5 times 10 to the power of negative 31. Okay, and then you square root the answer lah. So 1.6 times 10 to the power negative 19 times 3000 divide with 4.5 times 10 to the power of negative 31. Square root answer. So you get 3.3 lah. 3.3 times 10 to the power of 7. Okay. 3.3 times 10 to the power 7. Okay. Next. Now, diagram 3.2 shows a pair of magnets with opposite poles are placed at the side of the tube. So one of the shadows deflect. So by using an arrow, show the direction of the shadow which deflects. Okay, so shows the direction. So you see, the electron is moving, okay, from left to right. But your current, so current is supposed to be in the opposite direction. So this will be your current. Okay. And then you have your north and south. So this is your north and south. So you have to use your Fleming left hand rule. Okay. So it's like this. So use your Fleming left hand rule. So north to south this way. So north to south, point inwards. Okay, tunjuk ke dalam. Okay. So tunjuk ke dalam. And then your current must be on the other side. So you have to turn lah. So you have to turn. So north and south this way. So north and south ke dalam. And then your current this way. That means your force is downward. Okay. So force is downward. Electron going out. That means current going here. Going in. Okay. Electron going this way. So current is the opposite. So your force is downward. So what happens? The shadow will move down. Okay. So that means the shadow will be going down. Okay. So state the physics rule. So Fleming left hand rule. Okay, so Fleming left hand rule. Okay, so Fleming left hand rule. Okay. Now we look at past year question. Ini soalan past year. Now, diagram 4.1 shows a cross section of the multi-source tube, which is used to study the characteristic of the cathode ray. So the cathode ray is produced when electron emitted from the heated cathode. So name the process involved. So this one call it thermionic emission. Okay, thermionic emission. Okay, next. Now, diagram 4.2 shows a shadow and a green light region screen on the screen. So give a reason why the shadow is formed. So why the shadow is formed? Because cathode ray travel in a straight line. Okay, so cathode ray travel in a straight line lah. Okay, next. Okay, why there's a green light? Okay, green light region form. So why there's a green light? Because kinetic energy of cathode ray converted to light. Okay, so kinetic energy of cathode ray converted to light. Okay, okay, next. Electric potential energy lah 4.8 times 10^16. Okay, the calculate the velocity. So they usually give you the energy. So you just use half mv square equals to EV. So half. So your mass will be 9 times 10 to the power negative 31 times v square. Okay, so this one you already know the energy. They give you, right, 4.8. So right here 4.8 times 10 to the power 16. Okay, so pemudahkan ni sekarang bukan 4.5. So basically v square equals to 4.8 times 10 to the power of 16 and then divide with 4.5 times 10 to the power of negative 31. Okay, so square root the answer you'll get lah. Okay, square root the answer you get the speed of the electron. Okay, square root the answer you get speed of electron. Okay. Okay.
Halo.
What? Okay, now next D. Now diagram 4.3 shows two magnets in the opposite pole. This one sama macam ni. Okay, so I don't explain. So the answer will be same. That means you go down. So this question and question same. Okay, so ini sama saja. Okay, so let me point the arrow downward and then let me left hand rule. Okay, now one more example, number 20. Now diagram 4.1 shows a deflecting cathode ray tube. Now the function of filament is to heat up the cathode and release electron on the surface. So name the process. So thermionic emission. Okay, thermionic emission. Next, explain why a very high voltage use. Why we use the voltage, high voltage. So we want to accelerate the electron. Okay, so to accelerate the electron. Okay. Next, state the energy changes experienced by the electron from anode to screen. So the changes will be kinetic because you're moving. So kinetic to light. Okay, kinetic to light. Okay. Next. Now the voltage between the cathode and anode is 3000. The charge is 1.6. Calculate the kinetic energy possesses. Now this one they just want the kinetic energy lah. So what you do, you just calculate the electric energy. So just find the EV. Okay. So E will be 1.6 times 10 to the power negative 19. And then the voltage will be 3000. So you get 4.8 times 10 to the power negative 19 joule. Okay. So this one very simple because they just want the kinetic energy only. So they just want the energy. Okay. Okay, yeah. Next. Now, 1000-watt power supply is connected to the top of and lower plates. The top plate is connected to the positive terminal, the lower plate connected to the negative lah. So sketch the part of the cathode ray lah. Okay, sketch the part of the cathode ray. See what happened is, so here I based on this diagram. So this one connected to positive, negative. That means on top will be positive, down here be negative. So that means cathode ray, right? When it travel here, cathode ray is negative, right? So what happened will be deflected upward. So it deflected upward lah. Okay. So they ask you to draw a knot here. Dia suruh kamu lukis dekat sini. So you just sketch lah. Okay, tunjukkan dia deflected upward. Okay, how much is okay, how much it bend doesn't matter as long as it goes up. Okay, so dia akan deflect ke atas. Okay, what how much it deflect doesn't matter.
Bro.
Apa?
Tak ada saja. Aiman.
Okay, next.
Yeah. Hi.
Now,
Yo.
okay, from this answer, state one characteristic of cathode ray. So from here, we know that cathode ray is negatively charged. Okay, negatively charged. Okay, so these are some of the questions involving thermionic emission. Okay, so okay, others all question almost the same. Okay, so you must know what is thermionic emission, what is cathode ray. Okay, and then how to calculate the speed of electron. Okay, so that's all untuk hari ini. Manakah hujan lebat ribut putih sebelum elektrik putus, kita akan berhenti.
So tak sampai.
Hah?
Tak ada apa.
Okay, so we will continue
Alasan apa?
next week. Berapa orang? 17 orang saja.
Boleh lah.
Siapa lagi balik kampung yang balik?
Irham je.
Ha?
Irham je yang I tahu lah.
Yang geng-geng ni? Money changer?
Syafiq Ali balik kampung.
Apa? Rafi Ali?
Yes.
Siapa
Tapi
dia?
ada sebulan PKP lagi.
Siapa tu? Okay, dah.
Ha?
Dah lah, dah habis lah.
Thank you, sir.
Yes. Boleh sambung
Thank
tidur.
you, sir.
Pogu lah.
Pogo ni bodoh lah Pogo.
Kau bilang.